Hello guys, specifically the guy who asked me to make the video. Okay, I literally spent like a few hours trying to understand this because I did not learn this. I'm staying at home for my IGCSE study leave. So I tried to learn this. The last part of the last question is driving me insane. So I'm just gonna skim through this very quickly, okay? So water is flowing through a pipe whose diameter is 80 millimeters at a speed of 1 meter per second. صح? 80 millimeters. First of all, we will change it into what? We will change it into meters. So to change it from millimeter into meter, you are going to be dividing by 1,000. So if you divide by 1,000, you will get 0.08 meters. This is the very first step. The second step, to calculate the flow rate, we know that the flow rate is equal to the area times the speed. Now, how do we find the area? The area, it is pi r squared times the speed. We are given what? We know that the diameter is 80 millimeters or 0.08 meters. So the radius is going to be what? The radius is going to be 0.04 meters. So just substitute it. You're going to get pi times 0.04 squared times the speed, which is 1 meter per second. And then anyways, you're gonna get it to be 0.0016 pi cubic centimeter cubed per second. So the first option is an answer. Now another option would be in what? In liters per second. So how do we change it from centimeter cubed to liters per second? My bad, it's not centimeter cubed, it's meter cubed, okay? So how do we change it from meter cubed to liters per second? Very simply, we are gonna multiply by 1,000. So if you were to multiply by 1,000, you are gonna get it to be how much? To be 1.6, okay, pi liter per second. So the two answers are 0.016 pi meter cubed and 1.6 pi liters per second, okay? We move on to question number 2. In question number 2, they said the external dimensions of a closed wooden box are this. The thickness of the wood is this much. They want us to find the density of the wood. Okay, so first of all, to find the density of the, they want us to find the mass of the wood. To find the mass of the wood, we are given the density, but we need to find the volume. To find the volume of the wood, you will take the volume outside minus the volume inside. What is the volume outside? The volume outside, it is all of the given dimensions, so 20 times 15 times 14, minus the volume inside. The volume inside, because of the thickness, we need to subtract. Okay, so look, this is the box, yeah? Then you have the thickness that goes in from both sides. So if it's 0.5 centimeters, that means the total thickness that we should subtract from the dimensions is 1, because it's 0.5 times 2, because you have from this side and this side. Let's just say, okay, it's like this. Okay, so if that's the case, it's going to be 20 minus 1, which is 19, times 15 minus 1, which is 14, times 14 minus 1, which is 13. So you will put it on the calculator and you will get an answer of 742. Now that you have the volume, you will take the density 0.5, multiply it by the volume, which is 742, and you will get a mass of what? A mass of 371 grams. We move on to part 3. In part 3, they said the figure below shows a trough partially filled with water. It is shaped like a triangular prism. The cross sections ADM and BCN are equilateral triangles. The rectangle ABCD is a horizontal, and the triangles ADM and BCM are vertical. NC is 18 centimeters and AB is 40 centimeters. The height of the water on the container is 9 centimeters. Okay. Very importantly, they told us they want to find the volume of the water, but we know that the height given is 9 centimeters. And they told us that these are equilateral triangles. Okay, because they are equilateral triangles, then we can be able to use their properties. We know that the height will be 90 degrees. This, because it is an equilateral, this angle is going to be 60 degrees, and this angle, it will be an angle bisector, so it will make it 30 degrees. And when we are dealing with a semi-equilateral or a 30, 60, 90 triangle, we can easily find the value of one side. So we are given the value of the long side. To be able to find the value of the hypotenuse, let's say, so as you can see over here, we can use the SOHCAHTOA rule. We are given the adjacent and the hypotenuse. So we can use that cosine 30 is equal to 9 over the hypotenuse. So very simply, the hypotenuse is equal to 9 over cosine 30. So if you put it on your calculator, 9 over cosine 30 is going to give you an answer of 6 radical 3. So now you found what? You found the value of one side to be 6 radical 3. Okay? Now they want the volume of water. Here in this case, what we could do is we could find the area of the triangle and we can multiply it by the length. So what is the area of the triangle? Area of a triangle, it's 1 over 2 times sine the angle in between them, because it's an equilateral, it will have an angle of 60. So 1 over 2 times sine 60 times what? Times the length, times the sides. So times side times side. So it will be 1 over 2 times sine 60 times side. All of this is multiplied by what? It's multiplied by the length, which is 40. So if you put it on your calculator, okay, you're gonna get an answer which is 1870.614. What we're gonna do over here is we're gonna put it over radical 3, because as you can see in the answer we have radical 3. So you will put this number over radical 3 and you will get 1080. So very simply the answer over here is 1080. We move on to the fourth question. In the fourth question, they said, a sphere is inscribed in a cylinder whose height is the same as the diameter of the sphere. If the ratio of the volume of the sphere to the volume of the cylinder is this, what is the value of K? So they need the ratio of the volume of a sphere. We know the volume of a sphere is 4 over 3 pi r cubed over the volume of a cylinder, which is what? Which is pi r squared h. Okay, let us simplify it. Before we start, let's simplify it. You can cancel this and this. You'll remove the 2 here and you'll remove the 3 here. Basically, this goes away. And you'll be left with what? You'll be left with 4 over 3 r over h. Okay, we know that the height is the same as the diameter. Height equals diameter. And we know that diameter is equal to what? It's equal to radius. Or no, I mixed it up, my bad. We know that radius is equal to what? Radius is equal to diameter over 2. So very simply, it's going to be 4 over 3 times diameter over 2 over the height, which we know, which is the diameter. Now very simply, you can cancel what? You can cancel the diameter and diameter. You'll be left with 4 over 3 times 1 over 2. So it's going to be 4 over 6. If you simplify it, it is 2 over 3. So very simply, the answer over here, it is going to be 3. We move on to question number 5. In question number 5, they said the figure below shows a cone inside a sphere. The radius of the sphere OE is 9 centimeters and the radius of the cone EM is 5.4 centimeters. The figure is not drawn to scale. They want to find the volume of the sphere. We know that the volume of a sphere is 4 over 3 pi r cubed. Okay, so 4 over 3 pi times the radius of the sphere, which is given up to be 9 cubed. Put it on your calculator, you will get 972 pi. For part B, they said to the nearest integer the volume of the cone. How do we find the volume of a cone? Volume of a cone, it is 1 over 3 pi times r squared times h. Okay, so you're going to take it 1 over 3 times pi times the radius, which is 5.4 squared, times the height. Radius of what, by the way? Radius of the cone. Now the height, this is something interesting. How do we find the height? We know that OE is a radius, and if OE is a radius, then that means also what? That means ON is also a radius, and it's the radius of what? It's the radius of the big sphere. So in that case, that means ON is 9 centimeters. Now what's left for us to find is what? The value of OM. To find the value of OM, we can simply play Pythagorean theorem. So this is 9 centimeters, this is given as 5.4. To find OM, OM is equal to radical 9 squared minus 5.4 squared. And we will get it to be 7.2. So the total length, which is from N to M, it's going to be 9 plus 7.2, which is then 16.2. So very simply, it's going to be 1 over 3 times pi times 5.4 squared times 16.2. You will put it on your calculator, you will round it, you will get an answer of 495 centimeter cubed. So the answer here is 495 centimeter cubed. Part C, the circumference of a major circle of the sphere is whatever. How do you find the circumference of a circle? It is pi times 2 times r. So it's going to be pi times 2 times the radius of the sphere, which is 9. So it's going to be 18 pi. So the circumference of the major circle of the sphere, it is 18 pi. Now finally, if the sphere rolled 5 meters, how much is 5 meters in centimeters? It is 500 centimeters, okay? Across the floor in a straight line, it makes how many complete revolutions? To find the value of revolutions, it's going to be the total distance traveled, so dt means distance traveled, over the circumference, okay? But pay attention, they need complete revolutions. This is going to be very important. So the total distance traveled, which is 500 centimeters, over the circumference, which is 18 pi centimeters. You can put it on your calculator. And you will get an answer of 8.84. But how many complete revolutions? What's the whole number? The whole number is 8. So as the complete revolutions, you're going to take 8 complete revolutions. We move on to question number 6. In question number 6, they said, the figure below shows a cone filled with water to 1/27th of its capacity. Whenever they say capacity, they mean volume. Okay? The height and diameter of the cone are 36 centimeter and 21 centimeter respectively. The figure is not drawn to scale. They need the height of the water and diameter of the water. So very simply, they need the height and diameter. Okay, I will tell you. This seems hard, but it's a very easy question. We know that the ratio K of the volume, so it's going to be K cubed. Whenever we're dealing with volume, it's going to be K cubed. It is 1/27, so 1/27. That means if we are dealing with K, it's going to be the cubic root of both of them, which is what it will become 1/3. Now, K, we will use it when we are dealing with sides, with length. For example, we're dealing with the length and the diameter, we will use K. That means 1/3, we will use it over here, and 1/3, we will use it over here. Now, very simply, you will multiply the respective height, which is 36, and then the diameter, you will multiply it by 21. And like that, you will get your two answers. So over here, it's going to be 1/3 times 36, which is 12, and 1/3 times 21, which is 7. So respectively, our answers are 12 and 7. So we move on to question number 7. So here they said the container has a surface area of 3,600 centimeters squared. Okay, so keep in mind this is surface area, so the constant is k squared, and capacity, which means volume, and then the constant is k cubed. They also gave us the capacity for the second one, but they need the surface area. So in order to do that, what we're going to do is we're going to take capacity 1, which is 17.55, over capacity 2, which is 5.2. You're going to get the value of k cubed. So you put it on your calculator, and you will get an answer of 3.375. So then to find the value of k, you're going to do the cubic root of this value, and you will get that k is 1.5. Okay? Now, however, for the surface area, we will need surface area 1, which is 3,600, over surface area 2 is going to be equal to the constant squared. So k squared, it's going to be 2.25. So very simply, the surface area 2 is equal to 3,600 over 2.25. So it's going to be 1,600 centimeter cubed. So the answer over here is 1,600 centimeter cubed. We move on to the question number 8. They said select the correct option from the drop-down menu. RA, from here till here. So it is RA, okay? So RA, as you can see over here, it is going to be what? It's going to be both the median and the altitude. What does altitude mean? Altitude means the height. So RA is the height of triangle KRP or RKP, okay? And it is the median, meaning it will cut it into two equal parts. It will cut KP into KA and AP, okay? And they are both equal to each other. Now, the area of triangle RKP. In order to find the area of a triangle, what we will need to do is we will need to find the base, and we will multiply it then by the height and divide by 2. So the base, we know because it is a square, it's going to be 10. And the height, very simply to find it, we will apply Pythagorean theorem. So this is the radical 12 squared plus, if this is 10, then this is going to be OA, which is half of 10, which is 5 centimeter, plus 5 squared. You will put it on your calculator. So radical 12 squared plus 5 squared, you're going to get 13. So now you have the value of the height. So 13 times 10 over 2, you will get 130 divided by 2, and you will get an answer of 65. So very simply, the answer over here is 65 centimeter squared. Now the surface area of the pyramid, this is something very interesting. We know that it is what? It is a pyramid that has a square base. So in order to do that, we found the area of one triangle, area of triangle 1. How many triangles do we have left? We have 1, 2, 3 more triangles. So 1 plus 3, that's going to be 4 triangles in total, and they're all going to be having the same area. So you're going to take the area of one triangle, which is 65, and multiply it by 4 to get an answer of 260. And then you will add it to the area of the base, which is 10 times 10. And then you get 260 plus 100, and you will get that the total surface area is 360 centimeter squared. You move on to question number 9. So in question number 9, it says, the figure below shows a trough. Its bases are semicircles of radius 0.6 meters and its length is 3 meters. They said in part A. Okay, so they need us to find what? They want us to find the water needed to fill the trough. So in order to find this, we will need to find the volume of the trough. As you can see, the trough is half of a cylinder. So you're going to take the volume of a cylinder, which is pi r squared h, and put it over 2. So it's going to be pi. The radius, we know that it's 0.6 meters times 0.6 squared times the height, which is 3 over 2. Put it on your calculator. And you will get an answer of 0.54 pi. And just like that, we got our answer to be 0.54 pi. We move on to part B. In part B, it says, after being filled with water, a hole was discovered at the bottom of the trough. If the water is leaking at a rate of 2.5 liters per minute, then it takes the hole how many? Okay. Very simply, to move from meter cubed to liters, okay, we will need to multiply by 1,000. So 0.54 pi meter cubed is 540 pi liters. Okay. Now you're going to divide this by the rate. How many liters per minute? So 2.5 liters. Okay, so 540 divided by 2.5, you will get 216 pi minutes. So it will take 216 pi minutes for the hole to drain all of the water. Now this last question, I kind of found difficulty in the last part because I don't know, I even tried ChatGPT, it gave me a different answer. But I will try my best to help you guys understand what they want from it, okay? So honestly, for part B, please do ask your teachers. I will just write the closest I got to the answer. Because honestly, I keep on getting the same answer. Alright? So anyways, let's move on to part A. Part A is way easier than part B. So they said, if the volume of the remaining solid is whatever, what is the value of K? So how do you find the volume of the remaining solid, knowing that the figure below shows a small cone of slant height 10 centimeters removed from a bigger cone of slant height 15 centimeters. The bases of the two cones are parallel and the radius of the bigger cone is 6 centimeters. The figure is not drawn to scale. Okay, so the volume, in order to find that, we will need to be using the ratio. So we know that the ratio is K cubed. Okay? In order to find K cubed, we will need to find K. In order to find K, you can use what? You can use the side theorem. So 10 over 15. So let's say K is equal to 10 over 15. Okay? So that means K cubed is going to be equal to 8 over 27. Okay? And now they want us to find what? They want us to find the volume of the remaining solid. In order to do that, you will need the volume of the whole solid minus the volume of the removed solid. So the volume of the whole solid, it's going to be what? The volume of the whole solid, it's going to be the volume of a cone. We know that the volume of a cone, it is 1 over 3 times pi times r squared times h. So it's going to be 1 over 3 times pi, okay, times 6 squared times h. How do we find the height h? Very simply, to find the height h, you will need to be able to take this height over here. So to find this height over here, we can apply Pythagorean theorem. So we know this is 15, this is 6 over here. So this will be what? This will be radical 15 squared minus 6 squared. It's going to give us 3 radical 21. So times 3 radical 21. You put it on your calculator and you will get an answer of 108 radical 21 over 3. So now we have this value over here. So we found the volume of the whole cone. Now the volume of the removed cone, very simply to find it, we can apply the constant ratio. So it's going to be 8 over 27. Okay, 8 over 27. You are going to multiply it by the volume you found, which is 108 radical 21 over 3. Okay, you will put it on your calculator and you will get an answer which is 32 radical 21 over 3. So now you have the removed and the whole volume. So it becomes 108 radical 21 over 3 minus 32 radical 21 over 3. You put it on your calculator and you will get 76 radical 21 over 3. So very simply, the value of k is going to be 76. Now I used literally the same logic for part B. I did what? I did that k squared is going to be what? K squared. It's going to be 2 over 3 squared, which is 4 over 9. Okay. Okay, and then I found the surface area of what? Of the whole cone, and then I found the surface area of the removed cone and I subtracted, but it was not working for me. So let me try here again. So we know that the surface area of a cone, it is what? It is pi r L plus pi r squared. Okay. Okay, and I found it for the bigger one. For the bigger one, we know what? We know that r is equal to 6 and L, the slant height, is equal to 15. So I substituted, I got pi 6 times 15 plus pi times 6 squared. So you're gonna get 90 pi plus 36 pi. 90 plus 36 pi, it is 126 pi. So now I have what? I have surface area of the whole thing, which is 126 pi. I will subtract from it the surface area of the other one. In order to find the surface area of the other one, you're supposed to do 4 over 9 times 126 pi. And you're gonna get 56 pi. And now I will get 70 pi. But now an idea just came to my mind. They said they want also this base. So now we found the surface area of what? We found the surface area of this excluding the base. And all of this is 70 pi. So to find the surface area of this base up here, you're just gonna find the surface area of a circle. In order to do that, you know that the surface area of a circle, or the area of a circle, it's pi r squared. To find the radius, but you see, if I do this method, it's not gonna do anything. If we found all of this to be 70 pi, and we find the area of this pi r squared, we need to find the value of r. To be able to find the value of r, you will again use the constant k. So k is equal to 10 over 15. You're gonna then use 6, so times 6, you will get that it's 4. So you will get that this value over here is 4 centimeters. If that's the case, then it's gonna be pi times 4 squared, so it's gonna be 16 pi. You add them together, you will get 86 pi, and that will not give us the answer. The answer for them is 102 pi. Please do check with your teachers. I tried so many methods. I checked ChatGPT, I tried my logic, I don't know, I tried everything. I'm not able to get this. I'm not attending the classes. I'm so sorry for that because I have my externals. So yeah, please do check with your teachers. That's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day. Got to record the submitting, so here is the submitting. There you go.